From the swirling chaos of the Big Bang, a universe was born, a tapestry woven from the very fabric of space-time, studded with billions upon billions of galaxies, each a celestial island home to countless stars. For millennia, humanity has gazed upon this cosmic canvas, driven by an insatiable curiosity to understand our place within its grand design. This isn't just about distant lights. It's about our origins, our destiny, and the profound mysteries that underpin all existence. Consider, for a moment, the cosmic microwave background radiation. Not merely an echo, but the fossilized light of the early universe, a whisper from 13.8 billion years ago. It's the faint, uniform hum detectable across the cosmos, a chilling testament to a time when the universe was opaque, a superheated plasma. As it expanded and cooled, photons could finally escape, painting this ancient portrait of a universe just 380,000 years old. This isn't just a relic. It's a direct observation that validates the Big Bang Theory, offering a window into the very first moments after creation, before stars had ignited or galaxies had coalesced. It tells us that the universe wasn't always the sprawling, structured expanse we see today, but a dense, hot, formless void, pregnant with potential. And what about the dark? The universe, as we perceive it with our instruments, is largely composed of matter and energy that remains frustratingly elusive. We call it dark matter and dark energy, and together, they constitute roughly 95% of the cosmos. Imagine, everything we see, every star, every galaxy, every shimmering nebula, is just the tip of a colossal, invisible iceberg. Dark matter, we infer, acts as the gravitational glue holding galaxies together, explaining why they spin faster than the visible matter within them suggests they should. Without it, galaxies would simply fly apart. But what is it? WIMPs, macros, axions. Theoretical particles abound, but direct detection remains a profound challenge. The search for these ghostly particles is one of the most exciting frontiers in physics and astronomy, promising to revolutionize our understanding of fundamental reality. Then, there's dark energy, the even more enigmatic force that seems to be accelerating the expansion of the universe. For decades, astronomers believed gravity would eventually slow down the universe's expansion, perhaps even leading to a big crunch. But observations of distant supernovae revealed a shocking truth. The expansion is actually speeding up. This accelerating expansion implies a repulsive force, something inherent to space itself, pushing everything apart. Is it a cosmological constant? A property of empty space, as Einstein once theorized? Or is it something more exotic, a dynamic field, a quintessence that varies over time? The nature of dark energy dictates the ultimate fate of the universe. Will it expand forever, leading to a cold, empty, big freeze? Or will it eventually tear itself apart in a big rip? The answer lies hidden within the dark, driving forces of the cosmos. Beyond these grand cosmic forces, consider the extraordinary lives and deaths of stars. From the gentle collapse of a vast gas cloud, a star is born, burning for millions or billions of years through nuclear fusion, a celestial furnace converting hydrogen into helium. But every star, no matter how grand, eventually faces its demise. For stars like our Sun, it's a relatively gentle end, swelling into a red giant before shedding its outer layers to form a beautiful planetary nebula, leaving behind a glowing ember, a white dwarf. But for truly massive stars, the end is a cataclysmic spectacle, a supernova, an explosion so powerful it can outshine an entire galaxy, forging heavy elements like iron, gold, and uranium in its dying breath, seeding the universe with the building blocks for new stars, planets, and even life itself. We are quite literally stardust. And what might emerge from these supernovae? Neutron stars and black holes. Neutron stars are the ultra-dense remnants of collapsed stellar cores, packing more mass than our Sun into a sphere just a few miles wide. A teaspoon of neutron star material would weigh billions of tons on Earth. Some spin hundreds of times a second, emitting beams of radiation that sweep across space like cosmic lighthouses, pulsars. But if the dying star is truly immense, its core collapses beyond even the density of a neutron star, forming a black hole, a region of space-time where gravity is so intense that nothing, not even light, can escape. These aren't cosmic vacuum cleaners, indiscriminately sucking up everything. They are gravitational titans, warping space-time around them. We can't see them directly, but we detect their presence by their profound influence on nearby matter, often forming swirling accretion disks of superheated gas that emit powerful X-rays as they plunge towards the event horizon, the point of no return. Beyond our galaxy, the universe stretches into an unimaginable expanse of galaxies, each a complex ecosystem of stars, gas, and dust. We've discovered that galaxies aren't static islands. They interact, merge, and evolve. Our own Milky Way is on a collision course with the Andromeda Galaxy, a cosmic dance that will culminate in a spectacular merger billions of years from now, forming a new, larger galaxy we've affectionately dubbed Milkomeda. These galactic collisions aren't destructive in the way we might imagine. Individual stars rarely collide due to the vast distances between them, but the gravitational interplay reshapes the entire galactic structure, triggering bursts of star formation and creating breathtaking cosmic landscapes. And what about life beyond Earth? The tantalizing question of extraterrestrial life drives much of modern astronomy. The discovery of thousands of exoplanets, planets orbiting other stars, has transformed our understanding of planetary systems. We now know that planets are not rare, but common, and many reside in the habitable zone of their stars, where conditions might allow for liquid water, a key ingredient for life as we know it. Telescopes like the James Webb Space Telescope are now capable of analyzing the atmospheres of these distant worlds, searching for biosignatures, chemical fingerprints that could indicate the presence of life. The potential for life elsewhere in the cosmos is not just a scientific pursuit. It's a philosophical journey, challenging our anthropocentric views and expanding our sense of belonging in the universe. Are we alone, or is the cosmos teeming with life, perhaps even intelligent civilizations? The silence of the universe is deafening. Yet the search continues, driven by the profound implications of finding even the simplest microbe on another world. The frontiers of astronomy are constantly expanding. Gravitational wave astronomy, born from the detection of ripples in spacetime caused by the collision of black holes and neutron stars, offers a completely new way to hear the universe, revealing events previously invisible to conventional telescopes. Neutrino astronomy, detecting the elusive ghost particles that stream through the universe largely unimpeded, promises to unveil the most energetic and violent phenomena in the cosmos, from the heart of supernovae to the active cores of distant galaxies. These new observational windows are transforming our understanding of the universe, allowing us to probe its most extreme environments and uncover its deepest secrets. This journey through the cosmos is not just for scientists. It is a shared human endeavor, a testament to our innate desire to explore, to comprehend, and to connect with something larger than ourselves. Every new discovery, every answered question, only seems to reveal a deeper layer of mystery, a more profound complexity. It reminds us of the sheer scale of the universe, and conversely, the preciousness of our tiny blue planet, suspended in the vastness. It inspires awe, humility, and a renewed sense of wonder at the intricate cosmic dance that brought us into being. If you were captivated by these cosmic revelations and wish to delve deeper into the mysteries of the universe, subscribe to our channel. Join our community of cosmic explorers as we continue to journey through the latest discoveries, unravel the universe's most profound secrets, and ignite our shared sense of wonder. Hit that subscribe button and embark on your own celestial adventure with us.